In this video, we'll explore exponential functions involving Euler's number E. First, let's talk about evaluating an exponential function that models a real-world situation. To find an initial amount, what you would do is you would let the independent variable t equal 0. So you would plug in a 0 for t. To find an amount after a certain number of years, you would plug in the number of years for t. So now let's talk about this number e, exponential functions involving e. So e is called Euler's number, and it's a numerical constant used in mathematical calculations. The value of e is 2.7182818828 and so on, just like pi e is an irrational number, meaning that the values after the decimal point go on forever with no discernible pattern. The number e shows up in lots of real-world applications, such as population growth and finances. So let's do an example here. A species of animal is discovered on an island. Suppose that the population size, p of t, of the species can be modeled by the function p of t equals 400 over the quantity 1 plus 9e to the negative 0.3 t, where t is measured in years. We want to find the initial population size of the species and the population after 10 years and round our answers to the nearest whole number as necessary, because we're talking about a population of animals. So it would make sense to have a whole number. So for the initial amount or the initial population, we're going to let t equal 0. So we will have the population at time 0 is going to be 400 over the quantity 1 plus 9e to the negative 0.3 times 0. So 0.3 times 0 is really just the 0 power. And so this would equal 400 divided by the quantity 1 plus 9, and e to the 0 power would be 1. So really just 400 over 10. So the initial population size is going to be 40 animals. All right. Now we'll find out if the population is growing or shrinking. So we're going to go ahead and plug in 10 years. So after 10 years, we're going to let t equal 10. And so we'll have p of 10 equals 400 divided by the quantity 1 plus 9e to the power of negative 0.3 times 10. And that would become 400 divided by the quantity 1 plus 9e 0.3 times 10 would give me a 3. So this would be e to the negative 3. So I'm going to go ahead and plug that into my calculator. So I have 400 divided by 1 plus 9e, and to get to the e, I'm going to go to function here. Here's e to the x, so I'm going to hit e to the x, and then for the exponent, I'll go back to my main calculator and put in -3. So we have our 400 over 1 plus 9e to the -3, and the population rounded to the nearest whole number would be 276, so 276 animals. So after 10 years, my answer would be 276 animals. So the population is growing in this case. Okay, so remember, initial amount, you put in a 0 for your t. When they give you a number of years, just plug in that number for t. Let's look at a graphing problem involving e. So graphing an exponential function involving e. Here we have g of x equals 2/3 times e to the x plus 1, and then that whole expression plus 2. We're going to plot points on the graph and draw the asymptote as a dotted line, and then connect the points. So the asymptote is actually dependent on what you are adding or subtracting to your exponential function. In this case, we're adding a 2 to the exponential function. And so our horizontal asymptote is going to be at y equals 2. So I'm going to actually abbreviate horizontal asymptote as HA. So I'll have HA is y equals 2. So let me go ahead and draw that in before I actually figure out my points. So I'm going to grab the line tool. I'll draw it in as a dotted line. So I go to y equals 2, and I'm going to draw in my dotted line. So there's my horizontal asymptote. And this is the point y equals 2, or not the point, but the line y equals 2. Okay, so now let's go ahead and plot points for our graph. So what I'm going to do is I'm going to pick some x values, and I'll use the equation y equals 2/3 e to the x plus 1, and then the whole thing plus 2 to get a y value. So let's say I pick a -1, a 0, a 1, a 2, and actually let me pick a -2 also. Okay, so those are my values. So what I want to do is I want to plug those into this expression. So I'm going to go ahead and use the calculator. So my first one is 2/3. I'm going to do 2/3. To get the e, I'm going to go to the function menu and select e to the x. So I'll do e to the x, e to the -1 plus 1. And actually, let me go ahead and figure that out, simplify it a little bit before putting it in. So this would be y equals 2/3 e. If I'm plugging in a -1 for x, that would be e to the 0. This next one would be y equals 2/3 e to the first, because 0 plus 1 is 1. So just 2/3 e to the first plus 2. The third one would be y equals 2/3 e squared plus 2, because I plug in a 1 for x, I'm going to get 1 plus 1 is 2. Y equals 2/3 e to the third plus 2, and y equals 2/3. If I plug in a -2 for x, I would get a -1. So e to the -1 plus 2. Let me line these up just a little better. So I had 0, 1, 2, and -2. So here was x equals 0, x equals 1, x equals 2, and x equals -2. And we're trying to get our ordered pairs x, y. Okay, so now that I've simplified a little, let me come back over here and try that again. So I'll do 2/3 e to the 0, and e to the 0 will just be a 1, and then add 2 to that. So I'm going to get 2.67 as my y. So I'll have the ordered pair -1, 2.67. All right, now let me go back and do the same thing with when x is 0, I end up with e to the 1. So I'm going to have 2/3, go to the function menu, select e to the x. So we have e to the 1, and then we're going to add a 2. So we get 3.81. So I have the ordered pair 0, 3.81. Now when x is 1, we get 2/3 e squared. So I'll have 2/3 e squared plus 2. So I get 6.93. So I'll have the ordered pair 1, 6.93. When x is 2, I'll have 2/3 e to the third power plus 2, and I get 15.39. So I'll have the pair 2, 15.39. So I know that's actually going to be off of the grid that I was given, but that's okay. I'll have enough points to get my curve. So when x is -2, I will have 2/3 e to the -1, then plus 2, and I get 2.25. So -2 and 2.25. So 2.25. Okay, so I'm going to go ahead and plot these ordered pairs. And so I have when x is -1, I'm at 2.67. When x is -2, I'm at 2.25. So getting closer to that horizontal asymptote. When x is 0, I'm at 3.81. When x is 1, I'm at 6.93. So almost at 7. And when x is 2, I'm at 15.39. So way up there off the grid. So I know it's going to be a really steep graph. So I'm going to go ahead and connect these. I'm almost up against the horizontal asymptote over to the left. And then the graph shoots up really steeply to the right. And notice it has to go very quickly up, so very steep, in order to reach that ordered pair to 15.39. So we graph with the E the same way that we graphed our basic exponential functions like y equals 5/3 to the x. We pick x values, plug them into the equation, get our ordered pairs, plot them, and then connect them. The horizontal asymptote is depending on what you have added or subtracted to your function.